For decades, humanity had been the quiet joke of the galactic community. When Earth was finally welcomed into the Galactic Assembly, representatives from over 100 advanced civilizations gathered to observe the newest species to reach the stars. Expectations were low, curiosity mild. Humanity was considered a late bloomer, a species that had taken an unusually long time to move beyond its home system. The first presentation did little to change those opinions. Humans had arrived using chemical rockets. Chemical rockets. In a galaxy where many civilizations folded spacetime like paper, humans were still riding controlled explosions into orbit. It seemed inefficient, crude, almost embarrassingly primitive. Ambassador Relk of the Tharvian Collective tilted his translucent head, observing the human vessel displayed in the holographic projection. "You still burn fuel," he said slowly, "to push yourselves forward?" "Yes," the human delegate replied calmly. A ripple of amusement passed through the chamber. Several species communicated telepathically, and the sensation of shared humor spread like a silent wave. "How nostalgic," another alien remarked. "Do they also navigate using combustion mathematics? Perhaps wheels will be their next innovation." Soft laughter echoed through the hall. Humans did not react. That was what unsettled some observers. Most developing civilizations showed signs of insecurity when facing more advanced species. Humans did not seem embarrassed. They listened. They observed. They took notes. As if they were not here to impress anyone. As if they were here to learn. And learning, in the long run, was far more dangerous than pride. Far from the shining towers of alien capitals, deep within the Nevada desert on Earth, a small research facility operated almost entirely unnoticed by the wider galaxy. Inside worked Dr. Maura Vance, a human engineer whose reputation was built not on fame, but persistence. Her colleagues described her with one consistent phrase: "She refuses to accept limits." For over a decade, Maura had studied one fundamental question: why fight gravity when you could command it? Gravity was the weakest of the four known fundamental forces, yet it governed the motion of planets, stars, and galaxies. It shaped the structure of the universe itself, and yet remained deeply misunderstood. Advanced alien civilizations manipulated energy with precision, but even they treated gravity as an obstacle rather than a tool. Maura believed that assumption was wrong. Humanity had always been shaped by gravity. Every step taken, every structure built, every rocket launched had been a negotiation with the invisible force pulling everything downward. Gravity defined limits. So she began searching for ways to remove them. Her theories were considered unrealistic, too theoretical, too expensive, too uncertain. Funding committees rejected her proposals repeatedly. Many believed humanity should focus on improving existing propulsion technologies rather than chasing something that bordered on impossible. But history showed that impossible things often became inevitable once someone tried long enough. Flight had once been impossible. Breaking the sound barrier had been impossible. Reaching orbit had been impossible. Meeting alien civilizations had once seemed impossible too. And yet humanity had achieved each one through persistence rather than perfection. Late one night, Maura stared at lines of equations glowing across her workstation. The simulation results made no sense. Localized gravitational distortion. A measurable curvature of spacetime generated through comparatively minimal energy input. Her heart began to race. The numbers suggested something extraordinary. Not propulsion. Not weaponry. Control. She reran the simulation again, and again. Each time the outcome remained the same. A small region of space showed measurable deflection of external gravitational vectors. She whispered quietly to herself, "That shouldn't work." Yet the data insisted it did. Weeks later, a formal message was transmitted from Earth to the Galactic Science Forum. Humanity requested authorization to demonstrate a new defensive technology. Most council members almost declined automatically. Humans were known for resilience and creativity, but rarely for breakthroughs that altered fundamental science. Still, protocol required fairness. A small demonstration window was granted aboard an orbital testing platform near Jupiter. Few attended. Many expected entertainment rather than innovation. A modest human vessel docked beside the massive alien station. Compared to the elegant curves of alien engineering, the ship appeared simple, almost industrial. Functional, one observer commented dryly. Inside the vessel stood Mora Vance, monitoring her prototype. She felt no need for dramatic presentation. Either the mathematics worked, or it didn't. "Activating prototype," she said quietly. Outside the ship, nothing visible changed. No glow, no vibration, no obvious shield. Only silence. The alien observers exchanged puzzled glances. Then the station initiated a standard gravitic calibration beam. Harmless, routine, barely worth attention. The beam struck the region around the human craft. And curved. Not reflected. Not absorbed. Curved. Space itself seemed to bend around the vessel, guiding the beam harmlessly aside. The laughter stopped instantly, because bending gravity was supposed to be impossible. Silence spread across the observation chamber like a sudden vacuum. The gravitic calibration beam continued bending smoothly around the human vessel, its path curving in a perfect arc before dispersing harmlessly into empty space. No flare of energy appeared. No sign of strain rippled across the hull. The human ship simply remained still, as though the laws of physics had politely stepped aside. Alien scientists immediately began speaking over one another, their voices overlapping in multiple frequencies. Sensor malfunction. Impossible curvature radius. Energy output inconsistent with measured distortion. Instruments must be recalibrated. But the instruments had already recalibrated themselves 3 times automatically, and every result confirmed the same conclusion. Gravity itself had been redirected. Ambassador Relk leaned closer to the viewing field, his bioluminescent markings flickering with visible unease. "That is not shielding," he said slowly. "Shielding absorbs or disperses force." "Correct," replied the human observer calmly. "Then what we are witnessing," Relk continued, "is manipulation of space-time topology." The words carried weight. Even among advanced civilizations, manipulating space-time directly required extreme energy conditions, typically found only near stars, black holes, or massive quantum reactors. Yet the human vessel floated quietly, powered by an energy output barely greater than that of standard navigation systems. Inside the craft, Dr. Mora Vance studied the data scrolling across her console. The prototype field remained stable. Gravitational vectors were behaving exactly as predicted. External forces were not encountering resistance. They were encountering altered geometry. The gravity shield did not block incoming energy or matter. Instead, it adjusted the shape of local space-time, creating a subtle curvature gradient around the vessel. Incoming trajectories naturally followed the path of least resistance, a path that no longer intersected with the ship. It was not defense through strength. It was defense through inevitability. Back on the station, the test continued. A dense kinetic probe accelerated toward the human craft at high orbital velocity. The projectile contained no explosives. Its destructive capability relied entirely on speed and mass. A direct impact would have crippled most ships. Observers leaned forward. Impact approached in seconds. 3, 2, 1. The probe entered the distortion field. Its trajectory shifted smoothly, bending as though caught in orbit around an invisible celestial body. The object curved gracefully past the hull, missing by less than 2 meters before continuing onward into space. Several delegates visibly recoiled. One crystalline entity emitted a sharp resonance tone associated with alarm. "They are not stopping the projectile," it said. "They are removing the possibility of collision." Another observer whispered, "Probability itself is being altered." The implications spread rapidly. Traditional shielding relied on durability. Traditional evasion relied on speed. But altering spacetime itself eliminated the need for either. Inside her vessel, Mora monitored microfluctuations in the distortion field. Maintaining stability required extreme mathematical precision. Too strong a gradient could produce tidal forces dangerous even to the protected craft. Too weak, and the field would fail to redirect incoming forces effectively. The balance was delicate, but stable. So far. "Prepare Phase 2, Mora instructed her on-board system. Power distribution shifted subtly. External sensors recorded a slight intensification of curvature around the vessel. The visual distortion became faintly noticeable, like heat shimmer above desert sand. Then the impossible became stranger. Without firing thrusters, without emitting propulsion signatures, the human ship changed position. There was no visible acceleration, no detectable inertia signature. It simply slid through space as if friction had ceased to exist. Gravitational vectors beneath the craft shifted direction, creating a controlled descent through curved spacetime rather than linear motion. The ship was not pushing against gravity. It was choosing where gravity pointed. A stunned quiet filled the chamber. One senior physicist spoke slowly, as though afraid of confirming their own conclusion. "If this technology can scale, mass becomes irrelevant." Another added, "Acceleration limits no longer apply." A third finished the thought. "Structural stress constraints vanish." Military analysts began calculating implications instantly. Weapons designed to penetrate armor would fail. Defensive formations could be bypassed effortlessly. Fleet maneuver doctrines developed over centuries would become obsolete overnight. One realization emerged clearly across every species present. If humans could control gravity with this level of efficiency, they could ignore many of the universe's most fundamental limitations. And humans had introduced this breakthrough as a defensive measure, which raised an unsettling question. What threat had convinced them they would need such protection? Because throughout history, humans rarely built defenses without first imagining the dangers they might face. And when humans imagined dangers, they prepared thoroughly. The emergency council session convened less than 10 minutes after the demonstration ended. Representatives from the most advanced civilizations in the galaxy appeared as shimmering projections around a circular chamber deep within the orbital station. Some arrived physically, unwilling to trust long-distance communication for a matter this serious. The atmosphere felt heavier than normal gravity. For centuries, technological progress across the galaxy had followed predictable patterns. Improvements in energy efficiency, material durability, and propulsion speed had gradually shaped the balance of power between species. No single discovery had dramatically overturned that balance in generations. Until now, gravity manipulation had always been considered impractical on small scales. The energy requirements alone made such experiments inefficient compared to conventional shielding or faster engines. Yet humanity had achieved controlled gravitational distortion using comparatively minimal power. That meant one thing: their approach to physics was fundamentally different. Dr. Maura Vance entered the chamber escorted by 2 neutral security drones. She wore a simple dark uniform with no visible insignia. The lack of ceremonial attire was noted immediately. Many species used elaborate displays of status when presenting revolutionary technology. Humans, it seemed, preferred simplicity. Ambassador Relk initiated the inquiry. Dr. Vance, the Council requests clarification regarding the theoretical framework behind your device. Mara nodded once. The gravity shield is based on controlled curvature gradients within localized space-time. Instead of generating force fields, we adjust the directional flow of gravitational vectors. Several delegates immediately began cross-checking the terminology with their databases. One spoke sharply. "Your explanation suggests a violation of known efficiency limits." "Yes," Mara replied calmly. "Such violations are statistically improbable." "So were heavier-than-air flight models," Mara said. "So was faster-than-light travel, before it became common." Silence followed. Humans had a reputation for challenging assumptions considered settled by older civilizations. Another representative leaned forward. What motivated humanity to pursue such research independently rather than collaborate with the wider scientific community? Mara considered the question carefully. "History," she answered. The response generated confusion. "Clarify," Relk requested. "Human history shows a pattern," Mara explained. "Every time we believed we had reached technological stability, we encountered unexpected challenges. Environmental collapse, resource scarcity, global conflict, natural disasters, unknown variables forced adaptation." She paused briefly before continuing. "Human civilization survived because we assumed stability was temporary." The chamber processed her words in thoughtful silence. "Your species expected conflict?" one delegate asked. "No," Mara said. "We expected uncertainty." Another representative spoke. "You developed gravity manipulation as insurance." "In a sense," Mara replied. "If an unknown threat appears, humanity prefers to have already prepared solutions rather than react too late." Ambassador Relk observed her closely. "You anticipated encountering forces beyond current galactic capability?" Mara allowed a faint smile. "The universe is very large." No one disagreed. Recorded history already contained evidence of phenomena still poorly understood: ancient energy signatures, unexplained gravitational disturbances, and regions of space avoided even by highly advanced civilizations. Humanity's decision to explore gravity directly suggested a mindset focused on long-term survival rather than short-term advantage. Still, concerns remained. "If the gravity shield can redirect gravitational vectors," another council member said, "it could also concentrate them." "Yes," Mara acknowledged. "That would produce weaponizable tidal forces." "Yes. You are aware such capability could destabilize entire planetary systems." "Yes." The repeated confirmations did not reassure anyone. "So why," Relk asked carefully, "should the Council believe humanity intends to use this technology responsibly?" Mara did not hesitate. "Because we built it for ourselves first." She activated a display showing multiple recorded simulations. Human rescue ships entering high radiation zones. cargo vessels passing safely near unstable stellar remnants, evacuation craft surviving gravitational anomalies previously considered impassable. We designed the gravity shield to expand survivable environments, she explained. Exploration requires safety margins. Safety margins require new tools. The presentation continued. Models demonstrated how gravitational distortions could stabilize collapsing orbital habitats, deflect micrometeor swarms, allow travel through regions previously considered too dangerous for navigation. Not all innovations were weapons. Some were lifelines. Ambassador Relk folded his upper limbs thoughtfully. You are asking the galaxy to trust that humans developed the most strategically disruptive technology in centuries purely as a defensive measure. Mara met his gaze directly. Humans learned long ago that the best defense is preparation. Another delegate asked quietly, "And if the threat never comes?" Mara's expression remained calm. Then the gravity shield becomes what it already is. A tool that keeps people alive. For several seconds, no one spoke. Because the most unsettling part of humanity's breakthrough was not the technology itself. It was the mindset behind it. Humans were not reacting to known enemies. They were preparing for unknown futures. And historically, that approach had allowed them to survive challenges that should have ended them long ago. The Council had not yet reached a consensus when the station's early warning systems activated. A deep harmonic alarm resonated through every corridor, its tone unmistakable even to species unfamiliar with human-designed alert protocols. The display screens shifted instantly from Council projections to astronomical telemetry. A gravitational anomaly had appeared within the outer sensor perimeter. At first, technicians suspected instrumentation drift caused by the experimental gravity field still active around the human vessel. But secondary and tertiary sensor arrays confirmed the same disturbing reading. Mass concentration inconsistent with visible matter. Localized space-time compression. Unstable trajectory. One analyst spoke the words no station wished to hear. Microsingularity detected. A fragment of collapsed matter, likely the remnant of a failed stellar core or an ancient cosmic collision, had drifted silently through interstellar space for millennia before entering the system undetected. Objects of this size were rare, but not unknown. Their danger did not come from size alone, but unpredictability. Even a microsingularity possessed enough gravitational influence to distort trajectories of ships, satellites, and stations. Worst of all, they were difficult to track precisely. The anomaly's path intersected with the outer defense perimeter of the station. Evacuation protocols initiated immediately. Docked vessels began powering engines. Emergency calculations predicted structural stress risks if the singularity passed within 2,000 kilometers. Not catastrophic, but dangerous, unnecessary, avoidable. If warning had come earlier. Inside the human craft, Mara studied the incoming data stream in silence. The trajectory solution appeared unstable but not chaotic. With sufficient control of gravitational vectors. The possibility existed. A risky possibility. She opened a direct channel to the Council chamber. I request authorization to attempt trajectory correction. The chamber erupted in overlapping responses. Denied. Unacceptable risk. Human technology has not undergone sufficient validation. Unknown interaction effects. Mara listened without interrupting. Then she transmitted her predictive model. A simulation displayed projected gravitational curvature fields overlapping the singularity's path. A gentle redirection. Not stopping. Not containment. Guidance. Minimal interference with maximum precision. One council scientist studied the model carefully. The tidal gradients remain within safe margins, they admitted cautiously. Another added, field collapse probability is low, if calculations are accurate. Ambassador Relk considered the risk assessment. If the attempt fails, he said, only the human vessel is at immediate risk? Yes, Mora confirmed. And if the attempt succeeds? The station avoids structural stress entirely. Silence lingered for 3 long seconds. Authorization granted. Observation priority raised to maximum. All non-essential vessels withdrew to a safe distance. The microsingularity appeared visually as a distortion in background starlight, bending distant constellations into curved streaks. Its presence was subtle but unmistakable, an invisible wound in space-time itself. Mora activated the gravity shield at levels never previously tested outside simulation. Energy consumption increased, but remained within theoretical tolerances. The distortion field expanded beyond the vessel's hull, forming a controlled gradient extending several kilometers outward. External sensors recorded curvature shifts almost immediately. Gravitational vectors began tilting. Not dramatically, carefully, like adjusting the slope of a surface just enough for a rolling object to change direction. The singularity's trajectory altered by a fraction of a degree. Then another fraction. Observers watched telemetry lines update in real time. Projected impact probability decreased. 70%, 50%, 30%, 20, 10, 5. Each adjustment required constant recalibration. Even minor overcorrection could produce unpredictable gravitational turbulence. Mora's hands remained steady over the control interface. She did not rush. Gravity did not respond well to impatience. Gradually, the singularity's path curved away from the station's orbital zone. The distortion field guided its motion without ever directly opposing its immense gravitational pull, like steering a river by shaping the land around it. Minutes passed that felt far longer. Finally, the projected hazard zone cleared entirely. The microsingularity continued drifting through space on its new trajectory, posing no further threat to the station or surrounding vessels. No explosions. No dramatic flashes. Only a quiet correction of cosmic geometry. Inside the council chamber, no one spoke immediately. Several observers rechecked the telemetry repeatedly. Confirmation remained consistent. The human vessel had altered the path of a collapsed fragment of spacetime. One scientist whispered in awe. They did not resist gravity. They negotiated with it. Ambassador Relk slowly inclined his head toward the observation display. For the first time since humanity joined the assembly, no trace of amusement remained in his expression, because the species once dismissed as technologically immature had just demonstrated influence over one of the universe's most unforgiving forces, and they had done so with restraint. No one in the Galactic Assembly laughed at humans anymore. News of the gravity shield spread faster than any ship could travel. Within days, scientific networks across dozens of civilizations were flooded with verified telemetry from the demonstration near Jupiter. The data had been checked, rechecked, and confirmed repeatedly. Humanity had not simply improved shielding technology. They had redefined interaction with one of the fundamental forces of the universe. Gravity was no longer merely an obstacle. It had become an instrument. At first, many species reacted with caution. Revolutionary discoveries often disrupted fragile balances of influence. Military strategists quietly simulated possible outcomes, calculating how gravity manipulation could affect defense systems, navigation routes, and long-standing treaties built around technological parity. Yet what surprised the Council most was not the capability itself, but how humans chose to use it. The first production gravity shield units were not installed on warships. They were installed on rescue vessels. Human engineers partnered with multiple species to retrofit exploration craft designed to travel near hazardous stellar phenomena. Regions previously avoided due to unstable gravitational tides suddenly became accessible. Cargo routes shortened. Research expanded. Rescue operations, once considered impossible, became routine. Entire sections of space once labeled unsafe were reclassified as navigable. Humans shared the technology carefully, providing adaptive models that allowed other civilizations to integrate the principles safely without destabilizing their existing infrastructure. Dr. Moira Vance became known throughout the galaxy, though she avoided attention whenever possible. She continued refining the gravity shield's efficiency, focusing on stabilization protocols that would allow smaller craft to benefit from the technology. For her, the breakthrough had never been about recognition. It had been about readiness. Ambassador Relk requested one final private meeting before the Council ratified interspecies research agreements involving gravity field applications. The chamber was quiet compared to earlier sessions. The atmosphere carried curiosity rather than suspicion. "You understand," Relk began, "that your invention changes the strategic landscape of every known civilization." "Yes," Moira replied. "You also understand that the balance of power depends upon trust." "Yes." Relk observed her carefully. "Humans have historically been unpredictable." Moira nodded once. "So has the universe." The ambassador's bioluminescent markings flickered in faint amusement, the first sign of humor since the initial demonstration. "You anticipated resistance," he said. "We anticipated questions," Moira corrected. "And the answers? We prefer preparation over reaction." Relk inclined his head. "Your species invested decades pursuing a theory most civilizations abandoned as inefficient. Gravity shaped human evolution," Moira explained. "We evolved under constant pressure. Every structure we built required compensation for weight. Every step required resistance. Gravity has always been present." She paused briefly before continuing. "So we learned to think about it differently." The ambassador considered this perspective carefully. Many advanced civilizations had grown in low-gravity environments or developed early technologies that minimized gravitational constraints. Over time, gravity had become background noise in their scientific priorities. Humans, by contrast, had lived with its constant influence from the beginning. What one species ignored, another studied relentlessly. "What will humanity do next?" Relk asked. Moira gave an honest answer. "We will continue solving problems, even the ones that do not yet exist." That response carried both reassurance and quiet warning. Human innovation was not driven solely by competition. It was driven by curiosity mixed with caution, and history suggested that combination produced persistent advancement. In the years that followed, the gravity shield enabled missions deeper into uncharted regions of space than previously possible. Exploration vessels passed safely near neutron stars, mapping gravitational anomalies that had puzzled astrophysicists for centuries. Several species developed improved orbital stabilization systems using adapted versions of human curvature models. Emergency evacuation craft survived stellar flare shock waves that would once have destroyed entire fleets. Human engineers worked alongside alien physicists, refining the theoretical framework collaboratively. Knowledge spread. Capability expanded. Confidence grew. The laughter that once greeted humanity's arrival in the galactic assembly became something else entirely. Respect. Because the species once mocked for relying on chemical rockets had quietly achieved something extraordinary. They had learned not merely to endure gravity, but to shape it. And in doing so, humanity demonstrated a lesson older civilizations had almost forgotten. Progress does not always come from greater power. Sometimes it comes from refusing to accept that the universe's rules are final. Sometimes the greatest breakthroughs begin with a simple question. What if the limit isn't real? The galaxy never laughed at humans again. Instead, it listened carefully whenever human engineers said something was only theoretical, because history had shown that usually meant it was only a matter of time.